As I said, I would like to do a little bit of new stuff, which will not be on the test, and then I'm going to, I have a little practice questions to hand out that we can go through. We do have homework due today, and we can also, while we're doing the practice for the test, feel free to ask me questions about the homework, and I'd be happy to chat about it. But I wanted to do one example of a Turing machine calculation, and then, of course, we'll do many more, much more with this after the break. After the test. We already had the break. Although I suppose there is a little break also. Whatever. After the test, we will talk about Turing machines. One example of a Turing machine, just so that we can all see sort of what it looks like. Remember, a Turing machine has a diagram of states and such. And while it's computing, it has the tape, which is vaguely like a stack, but it's a lot more sophisticated because the Turing machine can sort of move back and forth along the tape and modify things on the tape as it goes. Anyway, here is an example. And like I said, the machine, describing the machine really is all done on a state-style diagram that's kind of like an NFA or DFA, and it has a starting state like that. The arrows have labels on them that look like this, and I will tell you what that means. A/A, R. So that means that if you're in state S, you can go back to state S. If you see A on the tape, you replace it by A on the tape, and then you move the head to the right. So this, what you see in one of these labels here, is sort of like, this is the read. If on the tape you see A, then this is the write. You change it to A, which really means you don't change it at all, but the machine is supposed to, every step, it reads something on the tape, and then it changes that thing on the tape, or maybe leaves it the same. This is a step which leaves it the same. And then this R means move to the right after you do this step. All right? So all of the arrows in my diagram are going to be labeled like this. This one says BBR, which means you can do that arrow if you see a B on the tape. You leave it like it is and move to the right. Here I have another BBR. I have a state called R, which is not really going to be confusing. CCR here. I got a CCR here. You're going to notice this is actually a very simple Turing machine. It maybe doesn't look like that, but I'm just drawing all the arrows here, and then I'll explain. And I have an arrow from T all the way to Q with a blank, blank R. Remember, the capital B means blank. It is possible that the tape may be blank in certain spots, and that's what the capital B means. So let me just say, I said this out loud, but a label like, X/Y, R means read X, write Y. That is, the Y will replace the X on the tape. And then move to the right. So that R at the end, actually, if you look at the Turing machine that I described here, all of the movement is always to the right. So this is a machine which never goes back to the left. That actually makes it quite a bit less sophisticated and a little bit easier to work with. And also, this machine never changes what's written on the tape. You can see all of my arrows are labeled by like A/A or BB or CC. That means that whatever it's reading on the tape, it's just going to leave the same. So this is actually a very simple kind of Turing machine which always moves to the right and also never modifies the tape. But anyway, can we think about what sort of how this thing looks like in a typical computation? So remember, the way to ask if a string is accepted or not is we begin, I explained this kind of badly last time, we begin with the input string written on the tape. And then the machine kind of does its thing, whatever letter it's pointing at, it follows one of the arrows about what step it should do at that point. We begin with the input string on the tape, and as far as accepting versus rejecting, the rule is if the Turing machine ever reaches an accepting state, this is a little different from NFAs and DFAs, but the way that this works is if the Turing machine ever reaches an accepting state, it immediately halts and the string is accepted. All right, this is different from like a DFA can arrive in an accepting state, but then leave that state and eventually reject the string. But that's not how we're going to do it with Turing machines. So whenever you get to an accepting state, it is automatically accepted on a Turing machine. All right, can we just do an example? I give you a string and you tell me if it is accepted or rejected. How about is AABC accepted? All right, so I'm going to try to copy this down so I don't have to scroll. And maybe I'll shrink it a little. Can I do that? Convert? No.
Has to be square.
A square selection?
Yep.
All right, I can handle that. How do I do it?
Oh, you just pull one of the quarters. No.
Really? That's not just going to make... Oh, all right. I thought that would just shrink the selection. All right, can you still read that? Maybe not. You have it on your paper, though, right? It's just got to be good enough. Okay, so how it works is we begin with AABC on the tape. I'm going to indicate that like sort of, like this. Now, actually, we are not, going forward, we're not really going to draw the tape in this way usually, but just so that it's clear the first time we do this, and then I'll show you how we're going to indicate this process. AABC, and you always begin the machine with the head pointing at the first letter and starting in the starting state. So I'm going to indicate that. I'm going to write the head like as a little hat here with a S in it. That means the head is currently pointing at the S and the machine is at the A. Sorry, the head is currently pointing at the first A there and the machine is in state S. All right? And what happens after the first step? Well, I see an A here. So I'm going to, from state S, the only thing you can do if you're going to read an A is this one right here. So I am going to read the A, leave it like an A, move to the right, and stay in state S. So the effect is, on the tape, I still have an A there, and of course I still have ABC in the other spots, but I have moved the head to the right, but still the head is in state S. So now it's like that. All right. This is quite a bit more complicated to keep track of than an NFA, but I mean, it's not so hard. Okay. We moved the head to the right by one spot, and we did not modify the tape because it said A/A. That means you read the A and you just replace it by another A. All right. Next step, actually the same thing will happen. I'm in state S pointing at an A, and so I have to do this looped arrow again. So I am again going to keep the A like it is and then move to the right and remain in state S. So now it says A, B. Now the head is here, still in state S. All right. Now something different will happen. I'm in state S and I'm going to read a B from the tape. That means I must, on the diagram, I must follow the horizontal arrow across, which says BBR. And so the B stays like it is. That's what the B/B means. You read the B, you replace it with a B. I move to the right, move the head to the right, and the head now is going to be in state T. So now it looks like A, B, C. The head is over here now and in state T. I move to the right, and I followed this arrow across from S to T. All right, we're getting somewhere. Now we have T. We are in state T. The head is looking at the letter C, and so I'm going to do this arrow here, CCR. That will replace the C, leave the C like it is, move the head to the right, and move the head into state R. So now I've gone sort of off the end, but remember, this tape, I'm not writing them every time, but there are blanks everywhere on the tape other than where that string is. So if you move off the end, there isn't really an end, you just get blanks. So this here is now in state R. All right. Now I am in state R looking at a blank. So from here, I don't follow this. This is if you're in state R looking at a C. I do follow this one, and it says BBR. That means if you see a blank, you leave it as a blank, move to the right, and go into state Q. And actually, this is the last step, so I'll just put it over here. A, B, C. So actually, I'm going to move to the right again, even further off the map, but it doesn't really matter. Now I'm in state Q, and the string is accepted because I went into state Q. That's all it takes to be accepted, is that you get to the accepting state at some point. All right. That's how we do it. Now, this actually is not typically how we're going to write this. Like I said, it's a little annoying to draw a picture of the tape like that every time. Anybody get some idea here of what kinds of strings will be accepted here? I don't know if you can get a feel for it. The head here is always just moving to the right in every step. Anybody have a feeling about this? This was AABC was accepted. Yeah?
A star, B star, C star.
He says A star, B star, C star. I think that's right. It's all strings which just have some number of A's, followed by some other number of B's, followed by some other number of C's. You can never have an A after a B. For example, like looking in the States, you can tell if you ever saw a B, then you would move over here. But over here, there's no opportunity to do anything for A's. And so the machine will get stuck, and that's how a string is rejected by a Turing machine, is that the machine gets stuck. I mean, that means that it never enters an accepting state. All right? So yeah, the language here actually requires all the A's to come first. Then you can do some B's over here next, and then you can do some C's next over here. And then if you get to the end after a bunch of C's and you see blanks, then it should be accepted. So really what's going to be accepted is things with a bunch of A's, followed by a bunch of B's, followed by a bunch of C's. But in any other order, it's not going to be accepted. Yeah.
You just said it.
Yeah, right. If you ever had, say, an A after a B, that's not accepted because you would have had to go across here when you did the B's first, but then you can't do the A from there. All right?
Would
Yeah.
AAC work though? Because you go to SR the Q.
Yes, AAC will work because you can do AA here and then down here and then across. Yeah. Yeah, so really A star, B star, C star, meaning that any of those could be empty if you wanted to. All right, great. Let me just say how we typically will write these. We write it like so. We're going to write each one of these sort of intermediate steps can be translated into, like, for instance, this one right here. A, B, C. Say it like that was one of my intermediate steps. This is going to be written as, they call these an ID also. These are like in a stack machine, they call these IDs. It's just a description of exactly what is going on at this particular step. The way that we're going to write this is like this, A, S, B, C. What that means is, here is the tape to the left of the head. This is the state of the head, and then this is the tape at and to the right of the head. All right. That looks kind of like a grammar step, but it's not. The S in the middle refers to the state of the machine. The A's on the left refer to what is on the tape to the left, and the B and the C refer to what is on the tape at and to the right of the head. And we are truly, so the true state of the tape is it looks like this, and it also has blanks, like infinitely many blanks stretching to the right, and also infinitely many blanks stretching to the left. But we're never going to write, all those blanks unless we have to. Like if the head actually arrives at a blank, then we're going to write blanks. But if I don't, I'm not writing the blanks here, but they are implicit. All right. So anyway, the entire previous computation that we did here. So our computation, AABC, looks like. So it begins with SAABC. That means only blanks to the left of the head, and now the head is pointing at the A on the first A, and then what remains on the tape is ABC after that. And then this becomes, in the next step, it became this. The head left the first A like it was, and then the head moved to the right by one's position and stayed in state S. And then in the next step, it again moved to the right, so it became ASBC. And then in the next step, it again moved to the right, but the state changed to a T. So next it was AABTC. And then in the next step, it again moved to the right, but the state changed to R. So the next step was AABCR, like that. And then in the next step, I hope I'm remembering properly. In the next step, so I'm right here now, right? And then in the next step, it moved one more position to the right and switched to state Q. AABC blank Q, right? The head has moved one spot beyond one blank, so you do have to write the blank in there. Yes?
Would you write another B at the end of the Q?
You can if you want to. I mean, this would not be incorrect, although my sort of convention is I'm never going to write any blanks on the two ends of the string, because there are always, like implicitly, infinitely many blanks on both sides. So you don't got to write them. If blanks occur somehow in the middle, then you do have to write them. All right. This is how we write a Turing machine computation. So let's just try in this example. What about something like ABA? This one will be rejected because of what I said before, but let's just see how it would actually work out. So you begin with SABA, and now my head is pointing at the A, and I hope you can still see your state diagram. The head will move one position to the right, leave the A like it is, and stay in state S. So now it will say ASBA. And now S, I'm in state S, and I read a B. It's going to move to the right again and change to state T. So this is A, B, T, A. And now is when we have a problem. In state T, if you look on the diagram, there is no arrow for reading a A from state T. And so this is stuck. This is because no outgoing read A arrow from state T. And so that means ABA is rejected. This is typically how a string will be rejected on a Turing machine, is if the machine just stops and can't go any further. All right, that's how we do it. So this is all I wanted to do for today. So we'll do several more examples next time of more interesting ones. Like I said, this one actually is not very interesting because it always moves to the right and it never changes the tape. This one is not very powerful, but machines which change the tape and move back and forth can do all kinds of interesting things. All right, I think that'll do it then. So I have my practice problems here. And like I did last time, I'm going to upload onto our usual spot this same file with the answers. I'm not telling you the answers just yet. I don't want to spoil it. So once you work them out, once you struggle a little bit, check out the answers on our website. Maybe I'll just say before you get to work here, the topics that will be on the exam is everything since derivatives through what's on the homework that is due today. So I would say that would include, well, it's basically derivatives, grammars, and stack machines. That's it. This includes, so derivatives is kind of like their own thing. You should know how to take the derivative of a set, and then also how to show that a language is not regular using derivatives. The way you do that is you somehow figure out how to take the derivative in many different ways, and then say all these derivatives are different. So there are infinitely many derivatives, so it's not regular. That's derivatives. And then grammars and stack machines, you should expect me to, well, questions like you see on the paper, but you should be able to convert back and forth from a stack machine to a context-free grammar. Those are equivalent. And then also you should be able to, create grammars or stack machines to make various languages. I think everybody knows what to expect. Anybody have any questions about what may or may not be on the test? I think it's pretty straightforward. All right, great. Let's get to work. So I'll walk around and see if you got any questions. I'm happy to answer questions about the homework, or even like old homeworks that didn't work out for you. If you have old questions, I'm happy to talk about that too.